Hi, this is M. Vaishnavi. Today we are solving homework 3 problem. Let's get into the video. So here the question given to us is that there's a hill which is there in this shape. Z is equal to this, and we are standing at a point P which is 60, 40, 996 as which has the coordinates in this form, and it's also given that positive y-axis is directed or is towards the north direction and the positive x-axis is towards east direction. The things we have to find out is three things. That is, first we have, if we walk due south, will we ascend or descend the hill, and at what rate will we do that? And if we walk due northeast, will we ascend or descend the hill, at what rate? The same question for both but different direction. And the third is, in which direction is the slope largest and at what rate will we ascend that in that direction, and what is the angle? To solve the part A of the question, we have to find out the rate and whether we ascend or descend the hill. For that, we need to find out the directional derivative of the function, that is nothing but the dot product of the gradient of the function and its unit vector and the unit vector at which we are moving. So for that, we know that unit vector would be minus j cap, as we are moving due south, and south is the negative direction of y-axis. So this is the function, and now let's find out the gradient of the function. That would be dou z by dou x I cap plus dou z by dou y j cap. Now we know this is the function, so by evaluating these values over here, we get minus of 0.01 x I cap plus minus of 0.02 y j cap. And we know one thing, that we are at a point P 60, 40, 966. So by evaluating these points in the gradient, we get the gradient value as minus 0.6 I cap minus 0.8 j cap. As we got the gradient of the function and also the unit vector, now the directional derivative of that function would be minus 0.8 into minus 1, that is plus 0.8. So as the directional derivative is greater than 0, that implies that we are ascending the hill and at a rate of 0.8. Now the part B of the question, that if we move northwest, the angle of that vector of our position vector would be 135 degrees from the positive direction of x-axis. So our vector would be u bar is equal to modulus of u bar into cos 135 I cap plus u modulus of u bar sin 135 j cap. So that would give us u bar is equal to modulus of u bar by root 2 into minus I cap plus j cap. Know that the unit vector or the u cap of this vector would be u bar by modulus of u bar, that is given out to be minus I cap plus j cap by root 2, and we know that the gradient of our function is given minus 0.6 I cap minus 0.8 j cap. By finding out the dot product of these two, we get du is equal to minus 0.6 into minus 1 by root 2 plus minus 0.8 into 1 by root 2. So that would give us minus 0.2 by root 2. That would come out to be minus of 0.1414. So now, as we know that the directional derivative of the function is less than 0. That implies that we are descending the hill, and at what rate are we descending the hill? At 0.1414 rate we are descending the hill. Now the part C, or the third part of the question, is that we have to find the direction at which the slope of the function is largest. And one point we have to note is that the direction at which the function of the slope is largest is the direction of the gradient of the function. So that implies that our u bar is nothing but the gradient of the function, which is minus of 0.6 I cap plus 0.8 j cap. And we know by finding out the modulus we got it as 1. So u cap will also be equal to minus of 0.6 I cap plus 0.8 j cap. The directional derivative of z is nothing but gradient of z into u cap. As we know that the gradient of z is also equal to u cap, we can write it as modulus of u cap whole square. And we know that two vectors multiplied by dot product will give us, if they are similar vectors, we get modulus of that vector whole square. So same happens over here, so that is we get 1. So as we know that the directional derivative of our function is greater than 0, it is ascending the hill at a rate, or having a rate of 1. Okay. So now for finding the angle, we need to find the value of tan theta, and tan theta is equal to dy by dx, which is nothing but the rate, and we know that the rate is 1. So tan theta is equal to 1, theta is equal to tan inverse of 1, that is 45. So theta is equal to 45 is our ultimate answer. Thank you.